This is question 83 from section 1 of the 2018 NSAA paper. So in this question, we're given C, which is a circle, with this equation, x plus 3 squared plus y minus 2 all squared is equal to 5. And we're told the length of the tangent from the circle C to some point P is 5 root 3. And we're asked to find, given all this, the shortest distance from P to C. So, how do we go about this? Well, we've got this circle, this tangent, this radius, etc. But we don't really know what it looks like. It's very hard to do anything with this without being able to imagine it in your head. And so we do what the logical thing is and what we wish the question had given us. We draw a diagram. So, first things first, let's have a circle. And we'll call it the centre of it O here. But it doesn't really matter. We know O is in fact at minus 3, 2 from here. But it's pretty irrelevant because this is a question concerning distances and general tangents. So we know P lies on some tangent, 5 root 3 down it. But by the symmetric nature of the circle, we can generalise and just say, we can just pick a tangent and work along that. So we could pick something like this or like this, but why do that when we can just pick something nice along the horizontal at the bottom? So we've got this point P here, and it is 5 root 3 away from the point of contact. So we've got to find lengths, so why don't we fill in any other lengths we can? So what about this distance from here to here? Well, that's a radius of the circle, but we know the radius squared is 5. And so this radius must be root 5. So here we are, but we seem to be not too much closer to the answer. But we've got to find out the closest distance between P and the circle. So what we ideally want to say is this, right? That it's along this line. But why is this true? It's very nice if it's true, but why? Well, the closest distance from anywhere to this circle, that line must be normal to this circle, right? So if we extend that normal line, it must pass through the origin, because any normal to the circle passes straight through the origin. And so our shortest distance must be here to here, where this line passes through the centre of the circle. So we've just got to find this distance here. But that also means we could just find this distance. Why is that? Well, we know this distance is root 5, right? Because it's a radius of the circle. So we can work out the distance PO and then minus root 5. We find this distance and we're done. So we just need to find this. Well, how do we do that? Well, remember circle theorems. If we've got a radius of a circle here and a tangent, what's this angle? Well, it must be a right angle. And now this is looking good because we can use Pythagoras to find the distance O to P. So distance OP is root 5 squared, so 5 plus 5 root 3 all squared minus the square root of 5, i.e. this distance. And we get to this form just by expanding out 5 times root 3, because 5 squared is 25, root 3 squared is 3. And that 5 plus 75 is root 80. And so minus root 5. So this is looking good. It would be helpful to get maybe this in terms of root 5, give that a go, see if something cancels or simplifies. So we know 80 is actually 16 times 5, so we can write it as this. But root 16 is 4, which is awesome. So collecting the root 5s, we get 4 minus 1, lots of root 5, which is 3 root 5. And that's good news, because one of our multiple choice options is C, and so our answer is C.